So when we look at this one here, this one is given in the general form or the standard form. And the standard form does give us lots of information. It does give us the expansion factor and direction of opening. So it's got a vertical expansion of 3 times. It opens down. The y-intercept is going to be the last number in that term. We can always double check by substituting in 0. X is 0. Yeah, that's going to be equal to negative 15. Now the y-intercept is only from the general form. Okay, we don't ever use the y-intercept from here in the graphing form. That doesn't work. We substitute in 0 for those ones. So the y-intercept here is negative 15. And the vertex we're going to have to find, well, we can find the vertex here by completing the square. We can find the x-coordinate using Vertex, but we'll just complete the square to get the y-intercept. So y equals negative 3, factor out the negative 3 out of the first two terms. We're going to leave that last term separate. Complete the square with 9. And we've added negative 3 groups of 9, so we have to balance that with a plus 27 on the same side. So when we've got the completed square, we can write it in the graphing form. So we end up with an x-coordinate of the vertex at 3, and the y-coordinate is going to be at 12. Okay, so the vertex coordinate ends up being at positive 3, positive 12. Okay, now for the roots, we need to be able to write this in factored form. So we're going to factor the negative 3 out of the first 3 terms. So in this case here, we factored the negative 3 out of the first 2 terms. Here we're just factoring. Okay, so we're going to use all 3 terms. So we're going to factor this to x squared minus 6x plus 5. Okay, so we're looking to 2 numbers that multiply to 5 and add to 6. Okay, so we're looking for x equals negative 5, x minus 5, x minus 2. So the roots of this function are going to be at 5, 0, and it's going to be from here, it's going to be 1, 0. So those are my roots. So when I sketch a graph of this function, okay, I've got my vertex at 3 over 12 up. I've got my y-intercept at negative 15 somewhere down here. Okay, so it looks something like that. Okay, so we have all the information corresponds with what we found here. The graphing form is what gives us the vertex. Okay, the factored form gives us the zeros. Okay, so we have to find the equation of these parabolas. We've given the vertex and a point. So if we're given a vertex and a point, what this leads us towards writing it in the vertex form or the graphing form. And when we do this, we're going to write in the vertex x minus 3, don't forget the square, plus 4. And we always have to remember that there's always an a value that we have to solve for. And this coordinate here is going to tell us the a value. So physically, this is what's happening. We know where the vertex is, 3 over 4 up. Negative 3, negative 8, somewhere down here, tells us the graph. It gives us now the shape of the graph. Okay, so just the vertex by itself doesn't tell us very much about the parabola. It could be a parabola that looks like that. But once we fix this point here, now we know that the graph is going to have to go through that point with a vertex at 3 over 4 up. Okay, that's not the greatest picture, but you get the idea. So I'm just going to give it one more try here. Okay, so what we need to do is solve for a, and we use that coordinate, negative 3, negative 8, as the x and y coordinate to be able to solve for the a value. So we end up with a. This is going to be x minus 3 let's clean this up a little bit, x minus 3 squared plus 4. Okay, so then we end up with negative 8. Now let's move that over. So negative 12 is equal to negative 6 all squared is 36a. So a works out to be negative 1/3. Okay, so it's kind of a fatter or shorter parabola upside down. So it corresponds with information given. So we end up with negative 1/3 x minus 3 squared plus 4. An equation with given in its root form, the roots are given in the y-intercept. Well, we could choose, the y-intercept does lend itself towards the general form, but the roots lend it towards the factored form. Now, ideally, the general form is probably the least favorable form that we want to use. So we're going to select the factored form. Not that we couldn't make the general form work, but it's much easier if we set this up with factored form. Again, we have to remember that there's always an a value that has to be solved for. So we're going to have roots at 5 and negative 6. And then we need to solve for the a value. Well, we plug in the y-intercept of 5 when x is 0. And then solve for a. So we end up with negative 30a equals 5. So a equals negative 1/6. So again, if we sketch a graph of this, we have negative 6, positive 5, y-intercept at 5. Okay, and it's probably some graph that's going to look something like that. Okay, it's upside down. It's kind of been squished down vertically with that compression factor of 1/6. So my equation then seems to match the information given, and I'm going to write my answer in factored form.